So our next topic is acceleration factor. Acceleration factor is nothing but a constant which actually is a real number, and this can be applied to improve the rate of convergence. Convergence is nothing but, see, for example, if we are going for Gauss-Seidel method, it has a flow chart and it takes n number of loops in order to reach the optimum output, okay, or a perfect output. And so if I am assuming that I have taken total 10 number of loops in order to reach the optimum solution, but if I am going to use this acceleration factor, then I will be multiplying this voltage in Gauss-Seidel method with this particular acceleration factor, then the number of loops that I need to take in order to reach the optimum solution will reduce, and hence I am using the word convergence. That is, it is reducing or it is converging the number of loops that needs to be taken in order to reach the optimum solution. So in generally this convergence is this is what exactly I said. The convergence is Gauss-Seidel method is slow is due to the fact that when voltage at any particular bus is updated, see, like if we have updated any one particular bus, then this particular updation will affect all the other buses also, okay. So it takes some more time in order to reach the optimum solution, and hence I am going to use this acceleration factor alpha. It's quite similar to the catalyst that we are using in chemical reactions. Over here in this load flow analysis, this acceleration factor acts as a catalyst which increases the rate of convergence, okay. See, if we have taken the perfect value of alpha, then it increases the rate of convergence. Increasing the rate of convergence means if I am going to take 10 loops in order to reach optimum solution, I can reach optimum solution at 5 loops only. But if I am going to select a wrong alpha value, then there is a chance that I am going to increase the rate of divergence because I am going to choose a wrong alpha value. So the divergence will increase. Like if I can reach the optimum solution at just 10 loops, then I am going to get 15 loops in order to reach the optimum solution. So this the number of loops that I need to take in order to reach the optimum solution purely based on what is the value of acceleration factor that I am going to consider. In generally, this alpha value ranges between 1.4 to 1.6, and in generally most of the time we recommend you to take alpha is equals to 1.6, and we can also take a complex number in order to see. It's purely depending on you what is the value that needs to be chosen in order to reach the optimum solution. But in generally, alpha value ranges between this particular value, but it totally is up to you whether to take which value, okay. But if you take a wrong value, then it is very sure that you may reach there is a high chances to you to get diverged in order to reach the optimum solution. So it is better to select a value between 1.4 to 1.6, and generally recommended value is 1.6 for alpha. So this is all about acceleration factor. Acceleration factor is nothing but quite similar to catalyst in a chemical reaction.